Here we have a problem to find the forces in the members of a truss, and we're going to use the methods of joints. The truss is off to the right here, fairly simple. 2-kip force going down at D, going left to right, a 2-kip force at B, and then reaction in the Y direction at C, AX and AY. So to find the reactions, are always our first step, is we're going to find the moments about A. Could pick about C, I pick A. Not going to spend a lot of time on this. Should know it by now. We get CY is equal to 1.75 kips going up. By observation, if C is 1.75 kips going up and the only other force is 2 kips going down, AY must be 0.25 kips going up. And if the horizontal force at B is the only force in the X direction, and that's positive 2, the AX, the only reactive force, has to be negative 2. The next step is we isolate, draw, and solve for a joint, one joint at a time. We try to pick the easiest joint, the joint with the least amount of unknowns. And if you look at A, it has 1, 2, 3, 4 members. We know 2, but 2 are unknown. B has 1, 2, 3, 4 members, one's known. D has 1, 2, 3, 4, one's unknown. And C, we see, has 1 known, 2 unknowns. I think that's the one I'm going to work on, trying to make it easier. And I draw the joint at C right down here. And we have CD, BC going, and I converted it from 9, 12, 15 to 3, 4, 5. Numbers are just easier to use for the slope of BC. Then we do our matrix, which gives the force, the direction, the X component, and the Y component. CY is the reactive force. It's going into a positive Y direction. 0 for the X, 1.75 for the Y, again positive. CD is horizontal. It's going in the negative X direction. We put a negative CD. There's no vertical component. BC is the member at an angle. It is the X component is 4 over 5 of BC, and that's going in a negative X direction. The Y component is 3 over 5, again, or better say this is in the positive direction. So I can do the sum of the forces in the X direction, sum of forces in the Y direction, and both have to be 0 because they're not moving. But I notice that the X has 2 unknowns, Y has 1 unknown. So I'm going to solve the equation for Y first. And the sum of the forces in the Y direction, 1.75, 3/5 BC, equal to 0. And when I solve that out, it's negative 2.92 kips. I then go and I solve it in the X direction, and I get negative CD minus 4/5 BC equal to 0. And you really have to watch your negative signs here. You're going to get screwed up. You got to be really careful. Negative CD minus 4/5 minus. So a minus of a minus is a plus, and I move this to the other side. I get CD is 2.34 kips. Forgot the kips there. Okay? And when we look at it, this is going up. We'd expect BC to be in compression. That makes sense. And I'd expect CD to be in tension. That makes sense too, because I'm sort of pushing this up, and this is going to hold it back, and that's going to be in compression. Then I just happily roll along, and I pick another joint. In this case, the next one I'm going to pick is joint D. And joint D is a little different. It has only the forces are in the X direction or the Y direction. There's no forces in an angle. And by observation, if CD is going to the right by 2.34 kips, AD is going to be going to the left at 2.34 kips. And if the outside force is 2 kips down, the upward force resisting is BD is 2 kips going up. And I just say by observation, that's enough, that's fine, we're good to go. I then solve the next joint, joint A. I could do joint B, but I think joint A is an easier, and I just draw it again. We know AX, AY, and AD. I know AD from this problem up here. So I just fill in my matrix, being careful of signs, being careful that I get the right angle for the x and right angle for the y. I can solve either of these because there's one unknown for each equation. I'll pick the x, no reason in particular. Maybe to check me, you'll see, and you'll do it for the y direction. Oh, pardon me, you'll do it for the x direction. It's negative 0.3. The last thing that I like to do is draw a summary force diagram. So you're going to redraw the truss, and this time, instead of labeling it, you're going to put the value of the forces in each member. So this is a compression of 0.43 kips. This is in compression 2.92. And the thing sort of makes sense when I'm looking at this pushing here. You'd press this, you'd expect this to be in compression. You'd expect this to be in a light tension. So you sort of, my arrow here is oh, this one should be up here. I got a little mistake here. And I got a little mistake, could be up there. So these sort of make sense. This is equivalent, this is equivalent, so it sort of makes sense. I put this here, all values in kips, then I don't have to write k's all these times, makes things a lot easier. So this is just a brief, simple example of solving the method of joints.